Yeah, hi everyone, Mr. Markwick here. The purpose of today's video is to go through how to rearrange a linear equation from standard form into slope-intercept form. The main difference you see when you look at these two different forms of a linear equation are that in standard form, which is sometimes referred to as general form, the variables x and y are both on the same side of the equation, whereas in slope-intercept form, the variables are on separate sides of the equation, and more specifically, y is the subject of the equation in slope-intercept form. It's by itself on the left-hand side. It's isolated by itself with a coefficient of 1. Slope-intercept form is useful because you can draw a straight line from looking at a linear equation when it's in this form. It's also easy to compare gradients of multiple linear equations to determine whether they're parallel or perpendicular. So slope-intercept form can be useful, and for that reason I'm going to show you how to convert or rearrange standard form into slope-intercept form in this video. Starting with my first example, which is 3x plus y equals 12. Now, the way I do it, guys, is I want to keep that y where it is on the left-hand side, but I want it by itself. So I'm going to get rid of everything else, or bring everything else across. Now, to do that, I'm going to get rid of this 3x. So instead of, this is a positive 3x, I'm going to subtract 3x from the left-hand side of the equation. And if I do that, I'm also going to subtract 3x from the right-hand side of the equation here. Now, just a note, guys, that on the right-hand side, 12 take 3x, they're not like terms, so I can't simplify that to a one-term expression on the right-hand side of the equation. I'll still be left with two terms over there, but that's what we want. In slope-intercept form, you've got two terms on the right-hand side, mostly anyway. The constant term could be 0, but in this case, that's fine. So now I'm going to cancel out my 3x take 3x, and I'm left with, on the left-hand side of the equation, y, with a coefficient of positive 1, which is what I want, equals 12 take 3x, but I'm going to write it as minus 3x plus 12, just like it is in the slope-intercept form over here, with the variable term x being the first term and the constant term being that second term. Okay, and that's it. That was just one step. Second example is x take y equals 7. Again, I'm going to bring over, or I guess get rid of that x from the left-hand side, and yes, bring it over to the right-hand side. It is a positive x over here at the moment, so I'm going to subtract x from the left-hand side of the equation, which means I also need to subtract x from the right-hand side of the equation. I'm then left with minus y equals minus x plus 7. That's a positive 7 up there. Alright, now I have to get rid of this minus sign in front of the y. Remember, y is the subject. It's isolated on the left-hand side with a coefficient of positive 1. At the moment, it has a coefficient of, that's right, negative 1. So, to get rid of that negative 1, remember negative 1y means negative 1 times by y, so the opposite operation of multiplying or timesing is to divide. I need to divide by minus 1 to get rid of the coefficient of minus 1. If I do that on the left-hand side of the equation, I also have to do that on the right-hand side of the equation. Now, this is the way I show it. I'm actually going to do it to both of those terms. So the minus x and the positive 7 are both going to be divided by minus 1. Okay, so I'm now left with, on the left-hand side, y, which is what I want, equals minus x divided by minus 1. A minus divided by a minus is a positive. X divided by 1 is still x. And positive 7 divided by minus 1, positive divided by negative is a minus. 7 divided by 1 is 7. So y equals x take 7 is my slope-intercept form of this original equation. Simple as that. The last example, in fact, let's just change this example a little bit, because I've had two examples with, well, positive 3x over here, positive x. Let's make that negative 4x. Take 3y equals 9. Now, the first thing, again, I'm going to get rid of that x term. So in this case, I'm going to add 4x. over here to cancel that out. But again, I need to do the same on the right hand side, so add 4x over here. That leaves me with minus 3y equals 4x plus 9. Again, that's a positive 9. Now I just need to get rid of this coefficient of minus 3. Again, what's happening between the coefficient and the variable y is multiplication. So the opposite of that is to divide. Divide by minus 3 on the left-hand side. If I do that, I need to do the same on the right-hand side. And I'm going to do that to all the terms on the right-hand side. There's 2 of them. So 4x divided by minus 3 and positive 9 divided by minus 3. That gives me, y on the left-hand side of the equation is equal to 4 divided by minus 3. Well, 3 doesn't go into 4, but it's a positive divided by a minus, so we're actually just left with minus 4 over 3x, and it's positive 9 divided by minus 9, which gives me minus 3. So slope-intercept form of the original equation is y equals minus 4 over 3x, take 3. There you have it, guys, converting or rearranging linear equations from standard form into slope-intercept form. Hope that helps.